First of all, thank you all so much for taking the time to come to this presentation. As Maddie mentioned, my name is Phillip Gangan. I am a sustainable design specialist, but also the marketing manager for regenerative design at HOK. And HOK, if all of you are unfamiliar with it, stands for Helmuth, Obata, and Kasabam. Those are the founders of our studio. They started the company in St. Louis, Missouri, in the 1960s. And we have since grown to, it's actually 28 studios. They keep adding a new office every other month. But we are 1,600 people working across the globe. So in short, we're big. We are a global design, architecture, planning, engineering, etc. Firm with very, very many projects. We are also very integrated and multidisciplinary, or interdisciplinary, as we'd like to say. We do everything from signage and wayfinding, mechanical, plumbing, electrical engineering, structural, sustainable design, workplace consulting, everything in the above, urban planning. We are also in a very broad sector or range of markets. We do everything except single family and multifamily homes. And when I say everything, I literally mean everything. And so the projects that I'll be showing to all of you in this presentation will be a snapshot of the different project types that we work on. So again, to give you a sense of scale, we don't do anything under 100,000 square feet. And I've been doing the calculations. That is 32,000 square meters. So nothing smaller than 32,000 square meters. We're big. Let's shortcut that. So sustainability in the built environment. So as a sustainable design specialist and marketing person, my job is to be able to communicate to our clients and to the public what we do and the services that we offer at HOK. And so we talk about, the world in which we operate in as the built environment, as opposed to the natural world, right? Because in the way I look at it, everything that is man-made is an artificial intervention on nature. So it takes the place of where nature should be, right? And so we as designers have sort of a responsibility to make sure that the buildings, cities, places that we design minimize the impact on that environment, because we're, again, taking the place of nature. All right, let's start with why. Why is it important? Why sustainability is important? So we know now, after many years of doing this work, that buildings actually account for nearly 40% of global carbon emissions, so greenhouse gas emissions, right? A lot of it comes from operational carbon. So all the energy use that we do in operating the building, but also embodied carbon. So the carbon involved in, let me try to get this right, extraction, manufacturing, production, delivery, and installation of any building material used in the building that actually accounts for a huge percentage of global carbon emissions. So in short, apparently we're the problem. That's actually a little bit close to half of greenhouse gas emissions comes from our industry. And so, we, again, as designers, understand that we have a responsibility to sort of address this. And to add to this, right, to reverse the impact of climate change, the UN estimates that we need to cut global emissions by 7.6% every year for the next decade. This percentage is actually very old. It's probably increased in the last few years. And so there is a sense of urgency that we need to act now, and we need to act collectively as a whole. So it doesn't matter if only one firm is the most sustainable firm in the world. It doesn't matter because its impact is so small compared to all the other firms globally combined. So we have come to many different agreements, particularly in the in the United States, and the UK, actually, to be fair, that it is a collective responsibility to solve this problem. And so many of the commitments that we have across the industry call for net zero energy buildings by 2030, net zero embodied carbon by 2050. This is our structural engineers industry. Our contractors also have a commitment to decrease greenhouse gas emissions through construction. We also have the Landscape Design Association also trying to achieve net zero and then hit targets for carbon sequestration. I know that's a lot of taglines, but we all, again, we know it's urgent. We all know that we need to do something, and we all need to do it collectively. At the same time, local, what do you call this? Rules and regulations for buildings, particularly in the United States, have also adopted stringent guidelines for buildings. So this is Cal Green. This is our green building code. It's mandatory for all buildings in California. They need to be net zero, new construction. They need to be all electric. There are a lot of rules in terms of renewable energy, biking and what do you call that? Electric vehicle parking and all of these things. So California and Washington, D.C. have the most stringent building codes across the United States. And actually, HOK has been very active in the development of these codes as a consultant to the local governments, right? So since it's our industry, we know what's best. We know that the targets are possible. And so we help the governments, the local government, set where the thresholds are, right? And so what is our goal? Our goal is to create cities, buildings, and spaces that sustain life. I hope that this is the same goal for all of you. It is the same for us. And to reduce the impact of the environment, the impact on the environment and people. So question for anybody, for everybody here. To reduce the impact on the environment and people, is that enough to get, as I mentioned, we are in a crisis. We need to stop climate change. Is reducing impact enough? No. So what we've learned and what we're seeing now is it is not enough to just minimize the impact on the built environment. What our buildings, spaces, and cities need to do is to create a positive impact. And so we have these concepts such as net positive, right? Net positive energy, for example. Can the building produce more energy than it consumes renewably through renewable sources and feed it back to the grid, right? Creating a more renewable, I guess, energy for the city or for the campus that it's in, right? Same thing with water. Can a building capture, store, clean, and basically return the water back to the municipal system, creating a net positive water building? So these are sort of the things that we are slowly trying to explore. We've implemented a lot of them over the years, and we continue to do so as the technology gets better, right? And so let's see. How do we do this? At least with HOK, we do it through an integrated design approach. We understand that architects can't just work in a silo because, you know, the building isn't just the building, it isn't just mass and form. We know that it works, it operates, it has structural systems, mechanical systems, it has furniture, interior design, signage and wayfinding, landscaping, civil, all that stuff. So if we bring all these disciplines to the same table and work together in a collaborative way, we produce sustainable results. We understand that we can't just pass along the plans to others and so that they can improve. We have to have a dialogue, an open discussion to make this work. And we have to be on the same page with the goals that we set. So.
HOK uses building science and sustainable design strategies to create high-performance, healthy, and resilient buildings. This evidence-based design process begins at the design proposal stage, working with our clients to create a sustainable vision for their project, understanding their goals around zero energy, water, and waste. Thereafter, we explore the client. How can massing and form finding be informed by the opportunities and challenges that nature gives us, so we can ensure solar access at the ground level, proper wind flow around the site to ensure outdoor thermal comfort. As we begin the facade designs, we utilize a parametric design process to optimize window-wall ratio areas. This provides for better thermal control. And this then creates the opportunity for daylight design, ensuring that every single interior space is enriched by natural daylight. And in the right climates, exploring the opportunities for natural ventilation, essentially a passive design process before looking at active design through advanced technology systems. Utilizing rainwater harvesting for chiller makeup and irrigation, and then looking to PV and other renewable solutions to create a sustainable operations plan. This connects people to nature outdoors while providing for a dynamic urban environment. This is HOK's integrated design process.
And so when we talk about sustainability, the good thing about sustainability is that it can be measured, right? You can't just say that your building is sustainable. You actually need the metrics to back it up and prove it. And we have the thresholds, right? The bad thing about sustainability is that it can be measured. You need to, you need to be able to, what do you call this? Prove that your building is sustainable through metrics and measures. This is what we call the Framework for Design Excellence. It was developed by the American Institute of Architects. So basically our association of architects across the entire United States and abroad, sort of as a guideline for the industry to really define what sustainability means. And we look at it through 10 different lenses, right? So equitable communities, ecosystems, water, energy, all of these different things. I'll touch a little bit upon all of them, some of them, and show you a few projects that we've done that really embody some of these measures. So first off, this is the Central and Wolf campus for Apple. It's in Sunnyvale, which is to the south, I'm going to say southeast of San Francisco. It's about 770,000 square feet or 235,000 square meters. It's big. It's a corporate commercial office building that we designed for a major real estate developer. We didn't design it for Apple in particular, but during the construction phase, Apple actually signed a long-term lease, and there we go. The idea was to actually create a campus that was divisible to accommodate multiple tenants. But since Apple wanted the whole thing, we were able to make it contiguous spaces to be able to create sort of like a headquarters or a second headquarters. And so, okay, looking at these two photos, it's the Apple campus on the left and then a normal mall on the right. Can anybody tell me sort of what is the difference between the two, particularly the photo on the right? A lot of parking. So typically within the United States and in California, you see a lot of developments like this, where it is a sea of surface parking surrounding sort of a building or a campus of buildings. Just because America is so vast and has a lot of space, they said we'll pave asphalt everywhere, right? So again, the built environment takes the place of where nature is supposed to be. That could have been a lush green space. And so what the idea for the Central and Wolf campus was to trade parking spaces for green space. And so if we take a look at sort of the site plan for it, so 3 sort of rings around, what do you call that? I think it was like a 1.2 acre site or something like that. The design preserves more than 50% of the site for open green space. So that was the whole idea. It's sort of like a machine in the park. Analogy. And so if you take a look at the image on the left, it was pre-development. This is what it looked like before, a cluster of really weird buildings. And then the building on the right is obviously our new campus. We've introduced like 92% native species to create more biodiversity, to create natural habitats for local flora and fauna. And pollinators and all of that stuff. 55% open space. We also, the cool thing is, 44 giant redwoods were actually preserved on site. So they were either kept in place or they were relocated to a part of the site. So as much as possible, we weren't trying to disturb the natural environment that was already in place, but we also set to enhance the environment that was there. So that's what we mean when we say we design for ecosystems. Everything that is there in terms of green space is there to enhance the environment. So to create a really lush, vibrant environment for the people of Apple. Yeah. And that's a really nice hero image. Pretty cool about the facade. As you can see, it's very, the curvature of it. What we've done is that we use parametric modeling to sort of design each of the panels for the windows specifically. Instead of installing just this one long panel, right, that is curved, which is very expensive and very technically difficult to produce, we created a panelized system. This also helps for window washing so that people can just come out and wash the windows. But also it's also spec'd to ensure that there is the most amount of daylight that comes in and penetrates the space. So I'll talk more about that later. So energy. From the sunny hills of Sunnyvale, we go to Hawaii. This is the, what do you call this? The Daniel K. Inouye Regional Center in Honolulu, Hawaii. It is for the National Oceanic and Atmospheric Administration. Basically, it's the weather people, right? So this is a weather lab in the middle of a tropical island. It is an adaptive reuse of two World War II airplane hangars connected by a new constructed atrium in the middle. A lot of it is for weather research, but also biomarine research. It's actually a pretty cool project. So we're talking about energy, right? The whole goal is to reduce the amount of energy use a building has. And we do that, as you've seen in the video, through passive design strategies, and also energy efficient mechanical systems. And so the whole idea is to reduce your energy as much as possible and to offset whatever remains with renewables to get a net zero solution. And so this is actually a very old project. It was completed in 2012. But even then, we were able to demonstrate this principle. So if you can see at the big atrium in the middle, we introduced a lot of skylights and daylighting into the space. We know that in Hawaii, because of the climate, there's sunshine throughout the year and throughout the day. And we wanted to harvest as much as possible in order to rely less on energy. Even though all the lights are LEDs, daylighting is really, really important for that. And in order to do that, to prove our concept, we use thermal imaging and daylight modeling to show, daylight penetration compared to, if you take a look at the image to the left, there's no openings. These were the original airplane hangars, fully enclosed. And slowly we bring in light through skylighting, clear story windows, and all that other stuff. Another thing, this entire building, and mind you, it's 106,000 square meters, is all naturally ventilated in the middle of, Hawaii, a tropical climate. What we use is this hydrolonic solution that captures the cool ocean breeze, bringing it deep through these chimneys that are there. And of course, it exhausts the hot air out. And yeah, 100% no mechanical ventilation for a building like this, designed during the time. It was very, very groundbreaking. And that's another really cool image. This actually won the AIA Committee on the Environment Award, which is like a top sustainability award for the industry. Okay, water. This is let me see if I can get this right. Parkway Pantai Glen Eagles Shanghai Hospital. It's a very long name. This is actually a design competition that we did a few years ago. It's 250,000 square feet, so more or less 84,000 square meters. It's big. The cool thing about this is we designed it as a living machine in order for it to be net zero water, meaning there's zero waste for water. Through rainwater harvesting and collection, sort of the rain is filtered through natural and mechanical systems and reused, as gray water for mechanical heating and cooling, plumbing, as well as irrigation. So there's zero waste for this system. And this is an example of sort of like a closed loop for net zero water. We worked a lot with our civil engineers to get this done. This is for another project, but it's just to illustrate how it works. But again, using the natural systems and sort of integrating it with the built environment to create a net positive solution for water. Okay, this is cool. This is designing for equitable communities. So we know now that buildings not just impact our clients and the users, but also the communities where the building is located, right? That's surrounding. And so the challenge of this is the Mercedes-Benz Stadium in Atlanta, Georgia. It's for American football, so the fake football, but it's also for the real football. It is, 2 million square feet, so 610,000 square meters. It's huge. It's one of the largest, apart from airports, it's one of the largest stadiums that we've designed. Let's see. And so you talk about, just because we've designed the building a specific project type for a specific function doesn't mean that it cannot benefit the surrounding community, right? It goes beyond its original function to give a positive impact to people around it. So we've located the site closer to downtown to ensure that everybody has equitable access to the site. It's very well connected by public transit. This is a light rail system. There's a stop right there. There's actually 2 or 3 stops close by. We encourage people to either walk or to use bicycles. There's a big bicycle valet parking that's there, but also use the bus. So again, trading parking space for green space, encouraging people to use mass transit, all reducing carbon footprint. Apart from that, we've designed the stadium to be very flexible. So during the off season, when there are no concerts or no games, the stadium is still in use, actually used every day of the year, either through alternative programs such as, it was an election polling station. It was a COVID-19 vaccine site or testing site as well. There are a lot of programs through not just through the stadium, but through the teams that play as well that help the community. So, we teach football to youth, to children and youth programs. There are a lot of, the whole thing actually becomes a big public yoga class, and it's open to the public. Anybody can come in. They use the whole thing. And so a few more other things that we've done, socioeconomic wise, it was actually located in a really low-income neighborhood that was really affected by flooding. So you'd think, right, like as an owner of this property, why would I invest in such a bad, quote unquote, location? But no, the owners of the stadiums did the opposite. They said we wanted a community asset, and so we decided to build here. What they do is they employ people from the low-income neighborhoods, surrounding neighborhoods, and train them and actually give them employment in terms of cooking or the concession stands and all of that stuff, really integrated there. The other thing that's really cool, all the furniture that's there, all the wooden furniture is actually designed and constructed by a group of homeless carpenters. Like they lost their homes during the recession and I think a little bit of the flooding. And so in order to help them out, the owner said, okay, we'll commission you to create all the furniture that we have using recycled wood. And so again, giving employment to your neighbors, being a good neighbor to the community you're in. One of the other things that I didn't show was there is a huge stormwater catchment that the stormwater system that the stadium has to mitigate flooding. Right, so they chose to locate it in a flooded area, and they chose to create a solution in order to address this just for the community in order to benefit them. And this is what it looks like. It's pretty cool. Again, parametric modeling to actually use the roof system. The roof closes like an camera aperture, right, and opens. But the structural system was actually, we used parametric modeling to design it to make sure that we don't over-design, we don't use more steel than should be, and to make sure that it works. So that was one of the cool things that we've done on this project. Okay, health, well-being, and equity. We know that our spaces affect us, the people who use it. We know that typically, in any given day, we spend 90% of our time indoors. And so interior spaces have a big impact on our health. The materials that we use and select also have a big impact on that. And so we want to make sure that our spaces are healthy and promote well-being and also promote equity. So this is the AstraZeneca South San Francisco site. It's a laboratory for the pharmaceutical company. It's both a research and manufacturing laboratory. Actually, one of the research for the COVID-19 vaccines was conducted here. And the whole idea for this project was to put science on display. Typically, if you're creating a lab environment, you put scientists in these really dark spaces. Like typically it's the basement or something like that. And so what we wanted to do was, in order to enhance their health and well-being, is to open up the laboratories You can see everything is transparent. The laboratories are enclosed in floor to ceiling glass that creates sort of like a transparency in between the spaces. It also helps to foster collaboration because you're not claustrophobic, right? You're not in just this enclosed dark space. It also allows for daylight penetration deep into the laboratories from both sides, actually. And the cool part about it is, if you look at the photo on the left, there are collaboration zones inside the laboratory itself, which is, you typically do not have that in the laboratory. But because of the laboratory's use, we were able to introduce these spaces. So the teams don't have to leave the laboratory, right? They don't have to take off their coats. They don't have to, wash their hands and whatever. They can actually just have their meeting inside, right? So it fosters quicker collaboration and innovation because you're already there. And so this is a typical floor plan. You can see the labs are, the south of the plan, the workplace is to the north, and all the enclosed and social spaces like meeting rooms, phone rooms, whatever, all concentrated on the core of the building because it doesn't necessarily need much light. We're talking about equity, right? If you take a look at the plan, particularly the workplace, there is no corner office. Remember, like in America, if you have in the United States, if you have a corner office, it symbolizes status. And you're the boss, you get the best view. What we did was we tried to democratize the spaces. Nobody gets a corner office, not at all, to ensure that, to make sure that it's collaborative, that it's equitable, everybody is on the same team. So the hierarchy structure is sort of taken away. You take away that physical space, it becomes more flat, right? Okay, this is also pretty cool. This is actually the egress stair. Are you guys familiar with the egress stair? No.
Like when you run from a fire?
Yeah. In the US, according to the building code, there has to be, it's like a fire escape. You have to install a staircase that runs throughout the building that exits directly outside. That's for in case of a fire, everybody can run out and go get out of the building as safe as possible. The cool thing about this is it's typically enclosed and it's typically tucked away in like the corners of the building. And for this, what we did for this sort of interior design is that we opened it up. The egress staircase is not what you would typically do to create sort of connections between each of the floors. And it becomes a vertical campus, right? So people can move up and down. It also encourages, it's active design, right? It encourages people to use the stairs instead of using the elevator, just to move around in their day. And so everybody sort of feels connected across like 4 floors of this campus because it's easy to get up and down. So simple step. The other one is we introduced biophilic design. Is everybody familiar with biophilic design? No, it's bringing in nature through either actual plants or patterns or sort of systems into the building or into our interior spaces to improve our health and well-being. So we know that being in a natural space actually enhances our well-being, makes us happier, makes us calmer. That's why we have like this really nice sort of atrium courtyard right there. And so we are able to do that even if it is a lab environment through natural graphics. And this is a really abstracted graphic of a local medicinal plant in the Bay Area. And so we've used that throughout the workplace and inside the laboratories as well. We've also made sure that we use healthy materials or natural materials. That's a wall of cork, the image on the left. Create special areas where people can come together, play games, de-stress, socialize, and also social spaces in between the workstations where people can just come together and have a quick meeting. And there's also a hospitality element that we brought in terms of like our furniture and also our finishes, just to make sure that people are comfortable and they feel like this is a place where they can, how do you call that? It's not all just work, but there are spaces within the building where they can come to either relax or decompress. Okay, let's move on to our second part. As a sustainable design specialist, we actually use a lot of digital tools in order to make the decisions or help our design teams make the right decisions in terms of sustainability. HOK has been using these really cool digital tools since like really, really early, since the computer was first created, basically. But we also still go old school and do models and all of that stuff. We're also looking into VR. But what I'm going to talk about is specifically sustainable design tools that we use. And so this is pretty cool. This is a small project that we're doing in Monterey, which is in the south of San Francisco. It's an 8-gate airport. And we think for us as a regional airport, that's small. I was told Montevideo has 4 gates. So, which is pretty cool because it's an international airport, right? So this is the Monterey Airport. It is approximately 10,000 square feet. We're not sure yet. It's currently in design, which is roughly about 3,200 square meters. And so in order for us to embark on a sustainable design for a building, we do what we call a nature of place examination. So you need to understand basically where the project is located and the different environmental factors that will help you design a better building. So for example, that's Monterey with a big circle that's there. It's actually in the Monterey Bay Peninsula. It's at the intersection of 3 different ecoregions. And all of these ecoregions have different landscapes, as you can see. So the mountainous regions of the Monterey Mountains, there's a couple of wineries, they're great. And then the dunes towards the sea. Each of these ecoregions have a distinct climate. They have a distinct flora and fauna. And we need to be cognizant of the environmental impact we have across all of these. So pop quiz. Does anybody know what the ecoregion of Uruguay is? No. I asked it at Slantis and nobody knew. Uruguay is actually called the Uruguayan savanna. So it's mostly flat with a few hills. And you have a few riparian forests across where the rivers are. So those are pretty cool. And again, this ecoregion has its own distinct climate that we have to think about in considering the building that we're doing, right? So this is a typical analysis that we do for the sun path and the wind to make sure that we have the proper building orientation. We also go a little bit more in depth to take a look at how intense the solar radiation is and what other factors can we do to influence the design. So really, really in depth. If you take a look at the chart on the bottom left, this is the outdoor thermal comfort, meaning how nice is it outside throughout the year, right? And if we take a look at Monterey, it's actually relatively nice. There's not that much temperature swings. And so what we've decided to do is to create a big open air courtyard in the middle of the airport. This saves a lot in terms of space because you're not, and budget because our client has a very small budget. But it's also an opportunity to introduce people to the outdoors and to be closer to nature. So this is a sustainable analysis tool that we use. This was developed in-house just to take a look at the different climate factors. And each of this gets modeled in detail as soon as we take a look at the design. So let's go through it a little bit. We use sort of a software called Climate Studio developed by Solema. Solema is a project by graduates from MIT. They were able to do this as their master's thesis to create a sustainable analysis tool. We sort of co-sponsored the development of the tool in collaboration with MIT. And as a result, we were able to beta test it. And we were also able to give feedback to fine tune the tool for commercial use. So, it's a give and take. We're the test dummies for the tool, but we also get to use it in the very beginning. And so we support it. It's actually a plugin for Rhino. So I'm not sure if you're familiar with Rhino software, but it's a very cool plugin. The other cool thing that we do is daylighting. As I mentioned before, daylighting, apart from the fact that it lowers your energy use, it also actually has a positive impact on us as people, right? it helps with our circadian rhythm that we're close to daylight as much as possible. And so the tools really take a look and, model sort of spatial daylight autonomy. We also take a look at glare, right? So if there's too much daylight coming in, you're going to get blind. We can identify the spots that are there and adjust the design accordingly. So in the middle of one of the building, you can see the courtyard that's carved out. We took a look at the daylight penetration to that and how that carve out would affect the rest of the spaces beside it. This is the same tool, just to give you a look at how it works. Everything is modeled specifically to a particular standard. So we use the LEED standard, if you're familiar with that. This is version 4.1. So we have to make sure that we're there. The other thing that we look at are views. Again, with the airport, we want to make sure that people know where they're going, right? For wayfinding, we also want to make sure that they're connected to the outside, because otherwise it can be confusing. And so we can also model the views while inside the building and take a look at the passenger sort of journey. So they don't feel like they're just in one big box. So again, this is what the tool looks like when we model it. Every small adjustment or increment to the model will give you a different result. And so what we try to do is try to find the most optimized result, show it to our design team, and give them options of what they can do. Okay, one last. This is the Stanford School of Medicine Center for Academic Medicine in Palo Alto. It's 107,000 square feet, so roughly 33,000 square meters. It's an office building, but it's an office building for the doctors at Stanford who teach. So all day, they're at the hospital teaching medical students, right? They're in a very, very stressful environment. A lot of them work in the emergency room or intensive care units. And we know that during COVID, right, the strain on the medical practitioners has been really, really bad, having to deal with all these patients. And so the whole idea for this center was to create a place away from the hospitals where the doctors can come and sort of find refuge. So it's a refuge of respite and rejuvenation. And so how do we do that? How do we heal those who heal others, right? We can do that exactly through design. And the way we've done this is we've let nature do the healing. And so the site is located, what do you call this? Like it's adjacent to the Stanford Arboretum, which is basically a botanical garden for trees. It's the largest public open space within the Stanford campus, which is insane considering it's a private, vast university, right? And so what we did was, instead of placing the building beside the Arboretum, why not put it inside? So our whole idea was to allow the nature and the Arboretum to flow in through the building and around it, creating a sort of lush green space with a healing quality to it. So everybody is just as close to nature as possible if you're looking at the buildings. The balconies up top give you views throughout the campus, throughout the Arboretum, even in the ground level. Everything is lush and green. And so letting nature sort of do the healing for you. And so, as we did with our other design tools, we took a look at solar radiation. So this is optimized for the best, to minimize solar radiation and glare, but to optimize daylight, as you can see in the two. And so we use sort of like a grasshopper script modeling tool to do this, to just see, what are the optimized openings and building orientation to get that. I think this is for outdoor comfort. So you're taking a look at the shading, you're taking a look at the facade as well, and the massing of the building. This is what it looks like to actually code the script to produce that animation. This is actually a small snippet of it. It's actually much bigger, but we use Grasshopper for this and other Ladybug tools as well. So yeah, a lot of coding. So the cool thing about this is, apart from the fact that we brought nature in, the 20% of the building program and vertical and horizontal circulation was actually moved outdoors and undercover. It's mostly a budget constraint, but it was an opportunity to actually bring people closer to nature and be outside by moving that program. So the whole idea is for you to collaborate or, to not just be at your desk the whole day, but to actually work, take your laptop, sit outside, have a meeting outside in the balcony or the courtyard, and just to engage with nature. And so in order for us to achieve this, to make sure that it was possible, we tried to model the thermal comfort outdoors. Because Palo Alto has such a Mediterranean climate, there are big temperature swings in the summer and the winter. So we took a look at, on the site, which buildings will be, which part of the site will be affected during those seasonal fluctuations in temperature, in solar radiation, also in wind. So for example, during the spring and fall, we invite people to sit where, what do you call this? Basically where the sun is, right? So you're tracking the sun. Through tables and chairs that are outside in the courtyard, we invite people to stay there, while the temperature is still a little bit low. It actually creates a really nice space to work in, during parts of the day. So we've activated the courtyard to ensure that. During the summer, when it gets really, really hot, people move actually to sort of the porch that we created. It's a 2-story porch in the middle of the 2 wings, if you can see there, that allows people to be in the shade. So I've actually done a formal post-occupancy for this, where we're taking temperature readings and airflow readings as well. And in the summertime, when it's very, very hot in Palo Alto, like around 35 degrees, it's actually like 5 to 10 degrees cooler under the shade. So we tested it, thankfully it worked. And so again, it allows people to move around the building in order to work outside, but also gives them the choice of where to work, right? So if somebody is okay being in the cold, they can work there. If somebody would like shade, heat, they could work there as well. So same thing I think for winter. We also brought, activated the space inside. This part sort of gets a lot of sun during specific times of the day. So even within the interior of the building, you're given these alternative spaces to work. So wind. We use computational fluid dynamics to test the massing and form of the building to make sure that we don't create a wind tunnel. So as I've experienced here in Montevideo, there's a lot of wind, especially if you're in between 2 buildings, right? The Venturi effect is very great. The wind just gets channeled and intensifies through that opening. And so we had to test, because there is a predominant wind in Palo Alto, whether it will be a comfortable place to be in, particularly during the summertime. And so we did extensive modeling to check the intensity, to check wind flow, wind patterns, just to make sure that the opening of the porch was big enough to minimize sort of that wind tunnel effect. So instead of getting a harsh, strong wind, you actually get a slight cooling breeze during the summer, which is actually pretty nice to work at. Yet you want that breeze when it's very hot. And so, yep, let's see that again. So yeah, that was one of the things. The other thing that we talked about again was biophilic design, right? Bringing people through nature. So this shows you how the arboretum flows through the courtyard, through that porch and around the building, basically surrounding it with nature. Again, this used to be a parking lot. And so we're trading parking spaces for green space. I think it was about 49% improved open green space for this project. And the cool thing about it, well, let's see, it's still moving. Oh, these are sort of like the areas where you get the most contact with nature because it's adjacent to nature. And the other nice thing about this, when we're talking about equity, is it's permeable. The entire building is permeable, meaning typically with developments like these, it cuts off access to the public space behind it. So people typically have to go around to get access to the arboretum. That's what we've seen with the other buildings close by. So what we've purposefully done is to create a permeable space so that people can flow and have the direct access to nature for the entire community. Another cool thing about it is the balconies and the bridges that you see there are open to the public. Anybody can just come in and experience nature if they want. They can work there, whatever they like. And so, right, instead of making it sort of like a public secure building for the users, we opened it up for the rest of the community. And we made sure they had equitable access to that arboretum. And so a few other images. This is, I think, what is it? The west facade of the building. Those are actually big metal screens that we installed. Initially, the screens were supposed to move and track the sun to provide shading, but that was really an engineering endeavor, so the client said no, because it's really, really massive. It's like 3 stories tall, very, very big. And again, each, if I go back, each phase of the building or the facade of the building sort of responds to its solar radiation. So, it doesn't all look the same depending on each phase of the building. It gets the most sun, a lot of sun in the east, and so we put these louvers as a mechanism, and all these other things. The other thing is we needed to adhere to Stanford's guidelines in terms of building materials. So they use a lot of stone and a lot of terracotta. And a lot of the campus, actually all the campus buildings across in Stanford look similar to this. And so just because the client gives you a constraint doesn't mean you can't find a creative solution for it, right? And so I think as designers, it's actually good that we're given a box to design in. Otherwise, right, our ideas will go crazy. But again, we're working with real money and real clients, and so we need to make them happy. This is another shot of the 2-story porch that's there. It's very, very massive. And you can see the benches and the seating that's there for people, can come in, can socialize. There's a small cafe as well that's open to the public. It's very popular, super packed during lunch. In order to improve connectivity, we've created these 2 bridges that cut across on the 2nd floor. So that, they don't have to go all the way around. This is, again, open to the public. If anybody wants to come in and just take a walk across the bridge or take a look at the nature in the balconies, they're more than able to do so. And again, we've tried to bring biophilic design into the workplace as well, using natural material like wood, but also views to the outdoors, right? So you can see, I think that's a eucalyptus tree. You have that here as well, through openings in the social spaces. So even inside, everybody has a view to the outdoors and a view to nature. That's a really, really cool balcony. We had a nice time photographing the project. And the nice thing, and what I've experienced really, just a side note, when you're up there, it's not just the trees and the sun that you experience, but also the sounds of nature, right? All the bird sounds. And what I loved about walking around the parks here in Montevideo and like Parque Roro and all of these places are there's so much wildlife and birds that I don't know. I mean, I'm sure some people get annoyed by it, but me living in San Francisco in that area, we rarely get to hear these bird sounds just because of all the buildings that are there. And so it's really, really refreshing to experience that. And so that's what we tried to achieve here as well for Stanford. Yeah, and there's a really huge cantilever for the building that's there. Yep, I think that's it. That's the last slide that I have. So if anybody has questions, yeah, take them.